Welcome to part 3 in the series where we'll be looking at aorta segmentation out of micro CT scans using Analyze Direct 14 software. In the previous part, we have pre-processed our data, and therefore in this part, we'll be looking at the segmentation options that we have. We'll be doing that by using this pre-processed file and the segment module inside Analyze Direct. And then you'll be greeted by these various panels here. In the left-hand corner, you'll be greeted by the various segmentation options that you have, as well as the segmentation tools, including edge strength, walls, and sub-regioning. And then you have the segmentation options that are semi-automatic or manual based. Here in the left bottom corner, we have our object manager. And how Analyze Direct works is that you have one big object map file in which you can have several different objects that you can place your segmentations in. You can very easily expand this by creating more objects, as well as very easily deleting them using the trash can icon. Furthermore, you can make sure that you can lock objects so that segmentations don't interfere with locked objects, as well as you can hide them, either by clicking on the lock or by clicking on the TV screen. Furthermore, you can rename stuff and you can change colors. Here on the right hand side, you'll be greeted with your different screen options, including your rendering, your axial orientation, your coronal orientation, as well as your sagittal orientation. You can change how these are positioned by clicking on the control layout, where you can select different views to be the primary image. You can make any of them your primary image, but I would also always like to use no primary image so that they're always equal and equal in size as well. Furthermore, here in your right top corner, you can select a toggle cursor link in which you can toggle the cursor links, which allows you to sometimes get a better look at the scan itself with no lines interfering with them. Furthermore, you have the object save options as well as the object save as options. And now we'll actually be going into the segmentation. I always like to start the segmentation by first clearly defining the bones inside the micro CT scan and therefore locking it so that they won't interfere with the aorta extraction. I always like to use threshold volume and under the semi-automatic tab, and thereby you can select various intensities to be thresholded out of it. You can see that as I scroll the bar in the thresholds, you can see that the image in the rendering very slowly decreases. And I would like to do that until there's nothing left inside of the thoracic domain except for bones. And you can check that using the axial, coronal, and the sagittal orientation views. Once you're sure that there's no soft tissue inside of there, you can click on threshold objects, and then you're left with this pretty rendering of the ribcage as well as the spinal cord. You can still see that in the rendering, you can still see that there are various specs of high intensity values, which are usually just produced by artifacts during the scanning process, but they will be of no concern for us. Furthermore, here in the actual orientation view, you can see how well the segmentation aligns with the actual positions of the bones. And in some regions, you can see that there's not fully overlapping or not fully segmented. You can further enhance that by clicking on Object Extractor, and thereby you can select several seeds, as well as defining a clear threshold, so that you can select different objects out of the micro CT scan based on intensities. I would just like to enhance this one single bone out of the ribcage so that it's fully extracted. And as you scroll through the different values of intensities in the bar, you can slowly select the region that you want to segment. And once you're happy with that, you can click on Extract Object. And sometimes you're greeted with this error in which it says that there's no point found. This is usually due to the fact that the value in or the region that you like to segment, the intensity values are not found within the intensity values that you have selected, in which you just have to increase your intensity selection. Once that's done, you can see that's very clearly defined, and you can do that for the different objects as well. Once they're better defined, I would also like to do one morphological object, one morphological operation in which I would like to dilate the ribcage. I do this because you can see that the aorta is very close to the spinal cord, and there are several situations in which you would try to use object extractor upon the aorta, but then it starts to also take a part of the spinal cord, and I would very much like to prevent that. So we have the dilate operation selected, and then we click on the spinal cord, and then it automatically dilates the entire object. Afterwards, I can lock this object, and that's done. That is the first step in the segmentation protocol, whereby we have very nicely segmented the entire ribcage and thereby also locked it so that once we start with the aorta segmentation, the ribcage will not be segmented at all. Next, we'll be starting with the actual aorta extraction, and how we want to look at that is first I make sure that the ribcage is a locked object, so it won't interfere anymore, as well as by making a new object, making it red, and by changing it into the cardiovascular system. Boom. There are various options that you can do this with. You can either do object extractor upon the aorta itself, or you can do a threshold volume based on the entire cardiovascular system. Hereby I'll try to show option 1, and again it's the same as the ribcage. You will use the threshold slider by sliding it through various intensities until you measure the ones that are overlapping with the contrast fluid instead of the cardiovascular system. Hereby I will slowly try to make sure that all objects of relevance are selected within the three orientational views as well as the rendering. And once I believe that's good enough, I can click on threshold project. And thereby we have our entire cardiovascular system of the thoracic region. You can get a better view in the render by hiding the ribcage. But as you can see, you get a lot of different artifacts that you would much rather not like to have. One of the options to get rid of this is by clicking on connected components. Hereby you can select a number of components in which the entire segmentation will be separated in based on the intensity threshold that you've selected. Click on find components, and there you have it. It will have selected the entire cardiovascular system into one object, the pancreas into another one, as well as the two scapula bones into its own separate object, and everything else that it does not believe is associated with anything, it has placed into the cardiovascular system object here. To remove these, we just simply delete these objects, and then they will return to the original object. And we will do this with everything that's not relevant. There we go. Rename this the cardiovascular system. And again, let's make it red for aesthetic sake. There we go. That's our entire cardiovascular system. Now we have a very nice cardiovascular system segmented into its own objects. And now it's time to extract our aorta out of this. Extraction can be done in various ways. Sometimes it's easier than others. But first, let's start with the first way. A very easy tool to use is Object Separator, in which we'll try to create a new object named aorta and make it a very nice color. With object separator, we can place two different seeds upon two different regions of an object. I'll place one here and one here upon the aorta. And with the seeds, you can associate them to which object you would like to separate them into. Seed 1 is associated with the cardiovascular system, and seed 2 is associated with the aorta. You can click on separate objects, and there you go. You can see how it separates them based upon the actual view alone, but how that spreads out throughout the entire object and also takes over the heart as well. One way to prevent this is by clicking undo and using the subregion feature in Analyze 14. Hereby we have three different controls for three different dimensions, the X, Y, Z, and we are only interested in using the Z dimension, where we'll be placing it just under the heart. Click on semi-automatic again, object separator, place your seeds again, and assigning them to the right objects, and then we can click on separate objects. And there we see how it only separates them in the region that you have allowed them into. So now the goal that we have is to separate the other regions that are slightly more well connected to the other arteries and veins. The other options that we can use to do this are more manual based, and thereby one very nice option here is to use the spline function or the spline trace function, and we can go into the corona slice, click the right button on our mouse, set object opacity, and then we lower it so that everything becomes slightly more transparent, and so we can see the borders between the inferior vena cava as well as the aorta slightly better. Hereby, the spline trace offers you a few selected options. Reset spline trace after apply and auto apply. I will select both. I will find the region in which I would like to start, and then hereby auto advance, press forward. And hereby you just start finding the borders of the aorta. To advance or to the next slice or to finish the spline trace, you just double press on your left mouse button. And this is just a little bit of manual work, but you get high detail compared to the semi-automatic methods. I'll speed forward this. As you can see here in the render, now the aorta is segmented or separated from the inferior vena cava, and that is well done. You can furthermore check your quality control by going over to the different actual slices. Hereby you see that I've also accidentally selected parts of a different artery. So we'll just be using object separator again by separating those. The first one into the cardiovascular system and the second one into the aorta. And there it is, separated. So furthermore, now the goal is to segment the aorta out of the top region, including the heart, which can be quite complicated sometimes, considering that if you scroll through the actual slices, you can see that the aorta gets pretty well intertwined with the entire heart, considering it comes out of the heart. One option again is by using object separator, using the subregion tool. We select subregion, but then only over the region where it gets out of the heart. Or we'll first start by putting it right over the heart, so we get nothing of the heart tissue with it, but only the aortic arch. Select our seeds and assign them to the right objects. Separate objects. And there we see how the aortic arch gets very clearly separated together with the brachiocephalic as well as the commoner scrotus and the clavine artery. And you can very clearly see that here as well by slicing through the different slices. What I will try to do now is just try to extract the entire aorta using object separator, which can sometimes be quite bothersome, but it has to be done. So I will try to speed up the process for now. Now, as you can see, I've placed the seeds upon the sagittal slices, and that worked a lot better than by placing them on the actual slices. This just proves that by using the different orientations, you can get a lot better results if you just know which orientation to use. And now we have to take out the aortic root out of the heart, and this is very nearly impossible to do with object separator, considering all the segmented places are all very closely interacted with one another. So for this, we're using spline trace once again, just by slowly going around this, and I will speed up this process again for you guys. And there we go. There we go. Now we have the aortic root, and I see that there's still some objects here that are connected to the aorta that are not part of the aorta. So we're using object separator again and try to separate those. And there we go. So now if we try to hide the cardiovascular system, no primary image. Hereby we can see our fully extracted aorta connected to all the aortic arch branches as well as the connections that it has towards the spinal cord. The spinal cord can be pretty annoying at times, considering the aorta and the spinal cord are just so very closely intertwined. But what we can do is again use object separator or using a more manual approach, both of which are just a lot of manual labor. I will try to speed up the process for you guys, but one way is, as I said, to use object separator, and the other process that you can use is by adding another object, calling it trash. We color this, let's say yellow. We go into manual trace or freehand draw, and hereby we can actually draw over the render image, and we can make sure that the stuff that you draw over with does go into the new object named trash. This way you can try to select everything in a very careful manner that you know that definitely doesn't belong to the aorta. For the bigger pieces, I will use object separator, which I've already made a start with it, and then you can just hide it so you can very nicely make sure that what you select is just only parts that you don't want to have. And you can see that this is the first very rough draft of the aorta that you have extracted out of the cardiovascular system and the ribcage. Now that was pretty simple, wasn't it? Hide. and hide. There we go. Now, further options that you can do to refine this aorta, just make sure that there are no abnormalities in the size or parts where you can see that's still sticking out of towards the spinal cord. Is you can either use propagate objects, filter objects, or morph objects. In this case, I would very much like to use morphological operations, whereby I would like to open close it. Oh, my bad. Open close it, and you can very clearly see the difference if you undo it and redo it. You can see that parts are already taken off and becomes a lot smoother, and it's a lot more refined. Yeah, there we go. That is the first part of the aorta extraction. Now what we want to do to make sure that we don't lose progress is by saving our object map, saving as, and then we just create here a new folder for the tutorial in which we save the object map. Save, and then it's done. And then we can close it and we can reopen it, and it should still be there. There you go. And that is the third video. Thank you for watching. Hereby we have segmented our very nice aorta out of the cardiovascular system and out of the ribcage. Thank you.